Hey guys, this is the 3-4 answer key for the review. So I'll just do 3-4 in this video. So in section 3-4, it says I'll be able to write quadratic equations in standard form. I'll be able to solve quadratic equations by factoring. So those are our two objectives in this section. So the first question says write a quadratic equation in standard form with the given roots. So if you are given two integers like this, it's kind of nice because you can just put those directly into parentheses with the opposite sign. So x minus 5, and then this one would be x plus 3, and set that equal to 0. If you're not sure where that came from, just as a sidebar, basically we know that x equals 5 and we want it to equal 0. So you would minus 5 and kind of work backwards and get x minus 5 equals 0. But it's sometimes easier to just remember that the sign just switches. So then what we would do is we would multiply those two roots, and we would get x squared minus 5 plus 3 is minus 2x. And then minus 5 times 3 is minus 15 or negative 15. And that equals 0. So this would be your, I guess we don't need the 0. It's just asking for the standard form. So x squared minus 2x minus 15. If you put the equal 0, it shouldn't be a problem. Okay. This next one, the second root, this one works out pretty nicely. That one's just going to be x plus 2. This first one is probably going to be a little bit more tricky, so I'll write this one out for you guys. So the way we would get this to equal 0 on that side is we would take it times 3 on both sides. So we would get 3x equals, these disappear, 1. And then we would subtract 1 on that side. So then you get 3x minus 1 equals 0. I'm sorry, this is going to get a little bit crunchy, a little bit messy, but then we have our two roots. So 3x minus 1, or I'm sorry, our two factors. Keep misspeaking. We have our two factors. I apologize. And then we can multiply these. So you can FOIL. This first example we could do kind of quickly with the shortcut where you add them to make the middle term and multiply them to get the end term. This one's a little different because we have the 3 as a coefficient right here. This one causes a little bit of a problem. So we end up with 3x squared. 3 times 2 is 6x. Then we would do the negative 1 times x is negative x. You could put a 1 there if you want. And then negative 1 times 2 is minus 2. Combine those things being these, and you would get 3x squared plus 5x minus 2. Okay, and then similar situation here. We would have for sure x minus 5 to begin with, and then over here, we end up with one that's a little bit more of a pain. So we would start by multiplying by 4 on both sides, and these are gone. You would get 4x equals negative 1, and then you would add 1 on both sides, and you would get 4x plus 1 equals 0. So now we have our two factors, x minus 5 and 4x plus 1. And we can multiply FOIL. So x times 4x is 4x squared. X times 1 is x. And then negative 5 times 4x is negative 20x. Negative 5 times 1 is negative 5. Last step, put these bad boys together, and you'd get 4x squared minus 19x minus 5. Okay, so then number 2 says solve each quadratic equation by factoring. So there's going to be some different ways that you guys could do these. But I mean, it's all factoring, but there's like little shortcuts that you might notice. So in this first one, part A, there's 3 terms. This coefficient here is 1. So what I would personally do is I would try to find 2 numbers that multiply to 20 and add to 9. So let's see, 2 and 10, no. -2 and -10, no. If it multiplies to a positive and adds to a positive, that means both numbers are going to be positive, just as like a heads up. So 2 and 10 doesn't work, 1 and 20 doesn't work, but 5 and 4, 5 times 4 is 20, 5 plus 4 is 9, so you would go x plus 5, x plus 4, set that equal to 0, and then you can set your 2 separate pieces equal to 0, but basically it's going to just end up being the opposite, so -5 and -4, because you would subtract 4, subtract 4. Here you would subtract 5, subtract 5. Okay, so those are your 2 roots. It's where it crosses the x-axis. All right, the next one, I see 2 problems. Not really problems, but I'd approach it differently because first of all, there's only 2 terms. We only have this one and this one. The second issue or problem or difference, I guess, is that we have this coefficient, which is a little bit of a pain. So what I would do is I also see that there's x's in both and there's numbers in both. So I would try to factor out numbers like the coefficient and any letters that they share. So both 5 and 30 are divisible by 5. I would pull out a 5. This has 2 x's and this has 1, so I would also divide by an x. So 5x squared divided by 5x, there's going to be an x left in this term. 30 divided by 5 is 6. X divided by x is 1. So we're just left with this. You can always double check. If you redistribute this, you end up right back at the beginning. So then you can set this equal to 0 and this equal to 0. Divide by 5, divide by 5. X equals 0. Add 6, x equals 6. Those are your 2 solutions. That's where that's going to cross. Okay, part C, this one I really like a lot. I see 2 things here. This I see as what's called a perfect square. It's a number that we know the square root for. And this this minus sign. That makes me super happy because it's actually pretty nice to handle. It's kind of like, if this doesn't make sense, you could do a plus 0x minus 36. Basically, it's asking what multiplies to -36 but adds to 0. And that would be 6 and -6. You don't need to write this out. This is difference of 2 squares. So this is x plus 6, x minus 6. This is a difference of 2 squares. So if you set those both equal to 0, you end up with 6 and -6. All right, part D. Again, I see 3 terms, coefficient of 1 right here. So I'm going to try to see if I can figure out 2 numbers that multiply to a negative and add to a negative. Now, when it multiplies to a negative, that means one of them is positive and one of them is negative. So they're going to be opposite signs. If they multiply to a negative, it means they're opposite. Also, if they add to a negative, that means the negative number is bigger. We can figure that out though. So to get to 30, I'm just going to list some of them. So we got 2 and 15, but one's got to be negative. So 2 and 15, 2 and -15, 1 and 30, and let's see, 3 and -10, -3 and 10, -5, 6, 5, -6. You guys don't need to write them all out. As soon as you see one that works, you can stop. So what I see is, again, what I was saying is they have to be opposite signs to multiply to a negative, and they need to make -7. That means the negative's got to be bigger by 7, so that's this one. So we would go x plus 3, x minus 10, set those equal to 0, minus 3, x equals negative 3. Here we would go plus 10, x equals 10. So those would be our two solutions. All right. This one, I did like factor by grouping is kind of what we would do with these. Because again, this one has 3 terms. This one only had 2. This one unfortunately has 3. And this coefficient is not 1. So what we're going to do is we're going to take the 2 and 12, which is 24. And then we're going to look at 11 from this guy right here. We're looking for 2 numbers that multiply to 24 and add to 11. That would be 8 and 3. So what we would do is we would go 2x squared. And then instead of 11x, I'm going to write plus 8x plus 3x, because that's still 11, plus 12. So I've just kind of rewritten this middle term right here as 8x plus 3x. Then we factor out the stuff that they have in common. So like this first part, we can take out a 2 and an x. 2 divided by 2 is 1, x squared divided by x is x. 8 divided by 2 is 4, x divided by x is 1. And then we do the same thing here. Pull out a 3, a positive 3, and 3x divided by 3 is x. 12 divided by 3 is 4. Now you'll notice we have the same thing twice. So what we're going to do is just pull out the 2x plus 3 in one parenthesis, and then we'll put the x plus 4 once. When you set those equal to 0, 2x plus 3 equals 0, minus 3, 2x equals negative 3. Divide by 2, divide by 2. So this is one of your x's, and then the other one is just negative 4. When you set this one equal to 0, it's negative 4. All right, and then this one will be another example like that. So we have 3 terms. The coefficient, unfortunately, is not 1. So we would take 3 and 10, and negative 10 is negative 30. And then we have a negative 1 right here. So what we're looking for is 2 numbers that multiply to a negative 30, which means they're opposite signs, and they equal negative 1s. That means there's not much of a difference. They're pretty close to each other, because when you do the positive and the negative together, there's only a difference of 1. Well, that would be 5 and 6 then. And since it equals a negative, it's going to be 5 and negative 6. So we'll have, let's try this color. 3x squared minus 6x plus 5x minus 10. Just one more time. I rewrote negative 1 as negative 6 plus 5 because it's still negative 1. And then negative 6 times 5 is negative 30. So then we look at this part and we pull out what those have in common. So we can pull out a 3 and an x, and we're left with just x minus 2. 3x squared divided by 3x is just x. Negative 6 divided by 3 is negative 2. X over x is 1. And then we do the same thing for this one. So we would pull out a positive 5. 5x divided by 5 is x. Negative 10 divided by 5 is negative 2. Now you see we have the same thing twice. So we're just going to rewrite that one time. And then down below, we're going to have the 3x and the 5. Set both of those equal to 0 because these are all equal to 0. 3x plus 5 equals 0. minus 5 minus 5. 3x equals negative 5. Divide by 3, divide by 3. So that's one of your x values. And then if you set this one equal to 0, you just get x equals regular 2.